Hi, so I'll be going over 1.1 homework on the textbook. I'll be going over problems 3.1, 3.3, 3.61, 3.65, 3.67 parts A and B. If there are any other problems you want me to go over, I can do that for you. Just hit me up on Discord. I will put my Discord in the description, and you can also just find me because I probably sent the link in the Discord somewhere. And I will also be sending the direct answers in the description in case you want to sit through the whole video. But I will be trying to make this really fast because you guys have a lot of work to do, and I don't want to take up your time with a big video. So yeah, real quick. So 3.1. The reaction between reactant A and reactant B is shown in the following diagram. Based on the diagram, which equation best represents the reaction? So we have four B's, as you can see, because there are four red spheres, and then we have four A2s because there are two clumps of A in each molecule. So we're going to say A2. That's really weird, right? 2. And then that will be forming 4A2B. Because as you can see, there are two A's and one B in each molecule. And then we can cross out all of these fours to simplify, as a 4-to-4 ratio is the same thing as a 1-to-1 ratio. Therefore, we can just clear it out completely. It's kind of just like simplifying. It is simplifying, actually. And that'll leave us with our equation of A2 plus B becomes A2B. And that matches up with answer choice A. So that is the answer. Now, 3.3. The following diagram represents the collection of elements formed by decomposition reaction. If the blue spheres represent nitrogen atoms and the red ones represent oxygen atoms, what is the empirical formula of the original compound, or what was it? So let's talk about what a decomposition reaction is first. A decomposition reaction is when a larger molecule decays into a smaller, different versions of molecules. So like, if we reverse this equation, this would be decomposition reaction, where A2B decays into smaller molecules, A2 and B. So let's do that. And also, an empirical formula is the most simplified version. So again, with 3.1, I got the empirical formula by just simplifying all of these fours out and getting that answer. So that is exactly what we're going to do in 3.3. So let's look at what we have. We have 1, 2, 3, 4, 5, 6. We have six O2 atoms, or 6 O2 molecules, and we have 3 and 2 molecules. Now we have to find a molecule that gives us that ratio of a 1-to-2 nitrogen to oxygen ratio. And what gives us that? It's going to be NO2. Or you could also write this out as N3O6, but the empirical formula, the most simplified formula, is NO2. So that is the answer. Next, could you draw a diagram representing the molecules of the compound that have been decomposed? Why or why not? We cannot, because we only know the empirical formula. We do not know the actual structure of the molecule. If anything, because, for example, the chemical structure of NO2 is very, very different from the chemical structure of N3O6. It's not like a simplified version of it. It's a completely different molecule, so it wouldn't look the same. So, yeah. So, no, that is the answer. No. All right, next problem. All right, so I pre-did my work before going over this problem, just for the sake of time. Hydrofluoric acid cannot be stored in glass bottles. It'll react with this, and it gives a reaction. So the main thing that these problems are testing you for is your knowledge of stoichiometry, which I hope you learned. I'll quickly go over it, but I really recommend that you check out one of my videos or go on Khan Academy or something to brush up on stoichiometry, because it'll be very important in Unit 1. So, part A, how many moles of HF are needed to react with 0.3 moles of sodium? Basically, this is just testing if you know molar ratios. How many moles of HF are needed? So you're going to be converting moles of sodium to moles of hydrofluoric acid. So you are going to use the reaction that you just given to find the moles. So from the reaction, you find that there are 8 moles of hydrofluoric acid for every 1 mole of sodium. So then you just multiply it by 8, just the way that I wrote it out, so that you can cancel the units, and you get 2.40. Now for part B, how many grams of NaF form when blah blah blah. This is testing if you know first molar ratios and then converting to grams. So same thing as before, you are going to use your molar ratios to find moles, and then you're going to convert to grams. By converting to grams, you're going to use the molar mass, which you can either use a calculator, the periodic table, or Google for. I use Google. And from that, you're going to be able to cancel your units and get to your final answer of grams. So grams of NaF, which is 5.25. And then for C, this is the same thing but with more steps. How many grams of So sodium can react with 0.8 grams of HF. So in this problem, there's going to be a lot of steps. First, you have to convert grams of HF to moles of HF, and then you have to convert moles of HF to moles of sodium, and then you have to convert from moles of sodium to grams of sodium. It's a long problem. But just do what I've been saying before, and you'll be left with 0.6 grams of sodium silicate. Okay, 65. Aluminum sulfide reacts with water to form aluminum hydroxide and hydrogen sulfide. Write the chemical equation. So I'm going to write this out and kind of talk about it. So I'm going to go over most of this. I'm not going to go over the balancing because that takes a very long time. But I'll go over like the actual writing it down. So you're going to be given the periodic table for most of this, for all of this actually. So you'll be able to decipher the chemical formulas of these compounds with the periodic table. For example, with aluminum sulfide, you know that aluminum has a 3+ charge just based off of looking at the periodic table. I haven't memorized this. I'm looking at it one right now, so that's how I know. Anyway, aluminum has a 3+ charge and sulfur has a 2- charge. So in order to balance this to get aluminum sulfide, you'll have to do 2 aluminums and 3 sulfides to get aluminum sulfide. And then you'll have your waters. And then in your products, you're going to have aluminum hydroxide and hydrogen sulfide. So again, you know that aluminum is a 3+ charge, and hydroxide, you should know, is a -1 charge. So we write this out as AlOH3 because there are 3 OHs to balance. And then finally, for your hydrogen sulfide, you know that sulfide has a 2- charge and hydrogen has a +1 charge, so you're going to need 2 hydrogens, and you have H2S. And this is going to be your incomplete chemical equation. The balance equation is 6 waters, 2 hydroxides, and 3 hydrogens. Okay, I wrote out the work for part B just for the sake of time. So part B is how many grams of aluminum hydroxide are obtained from 14.2 grams of aluminum sulfide. So for this problem, you're going to need to use the equation from part A to answer it. First thing you need to do is convert your grams to moles, and then you need to convert your moles to moles aluminum hydroxide, and then finally convert that to grams. So just briefly, you're going to find the molar mass and just cross that out, and then you're going to use your molar ratios. From here, you know that there are 2 moles of aluminum hydroxide for every 1 mole of aluminum sulfide. I'll circle down the equation. So then that gives you your molar ratios. You can just cross that out. And then you'll find finally your grams, and that'll be using a periodic table. And you'll get your final answer, which is 14.7 grams. All right, 67, last problem. I'll be going over parts A and B. There's also part C, but that wasn't on the homework. So anyway, this is just saying that sodium azide decays into sodium and nitrogen, and it gives the equation too. So part A is asking for the moles of nitrogen when 1.5 moles of sodium azide are decayed. This is a pretty simple problem. All you're going to be doing is your molar ratios. So you're going to have your 1.5 moles of sodium azide, and you're going to be multiplying it by your molar ratio. So for every 3 moles of nitrogen, you have 2 moles of Na, 2 moles of sodium azide. So those units cancel, and you get 2.25 moles. All right, part B. How many grams of sodium azide are required to form 10 grams of nitrogen gas? So this is a long problem, but it's the same logic. I'm going to write this out. Hold on. Okay, I've written it out. So all we're going to be doing is converting a bunch of times again. So first thing you do is convert grams of nitrogen to moles of nitrogen. That is just going to be using your molar mass, which is just 2 nitrogens. And then you're going to be using your molar ratios, 2 moles of sodium azide for every 3 moles of nitrogen. Cancel those out, you get your new units, and then finally you're going to be converting that to grams to get your final answer, which is 15.5 grams. And that's all. Thanks for watching and enjoy your night.